Hello, trig class. We are starting a new unit and it's still involving trig, all things trig. And today we're going to look at our trig IDs. We're going to take them out and dust them off. I don't believe there's any new ones, but I would like you to find your trig IDs in your comp book. If you do not have that with you, then jot these trig IDs down on a piece of paper. If you have your comp book, find the page with all the trig IDs and make sure all of these are on it. And then we'll go from there. So the first trig ID should be known to you because we had to use it to find the value of when we were looking at the curve called the tangent curve. We had to know to graph the cosine first, and where it zeroed out we found the asymptotes. So we've used that one recently, and the flip of that, cotangent, is cosine over sine. Forgot to flip it. Alright, so tangent is sine over cosine, and cotangent is cosine over sine. Alright. Now I know that they're labeled, numbered differently in your comp book, so don't let that. In fact, I won't number them. Just keep the numbering that we have, which I do not need to match at this time. Alright, these are very useful. That's why I put them at the top of our list. Then comes the reciprocals. So what is the reciprocal of the sine function? It is the cosine function. And likewise, the cosine is the reciprocal of the sine. This relationship repeats itself for cosine and secant, and again with tangent and cotangent. So every function has its reciprocal function. So there we have those. Maybe I get a little better angle there. Alright, so let's group these. These two come out and play so often. I'll just put them in a group, but I don't really have a name for it. And notice that I can rewrite tangent in terms of sine and cosine. I can rewrite cotangent in terms of cosine and sine. That's all I can call it. But then when I get to these six, I'm going to call those the reciprocals, because they are reciprocals of one another. So when I refer to them. The next one, we practiced this in class today. And for those who weren't in class today, all we did was go get our tests back, finished our damped trig functions, and then practice trig IDs. So here's the first of this group, and I'll name it in a minute. Sine squared x plus cosine squared x equals 1. And we developed all these earlier. And 1 plus tangent squared is secant squared. Notice all of the trig functions are squared. And lastly, 1 plus cotangent squared is cosecant squared. And this is a group, and we're going to call it the Pythagorean IDs. And they were developed, and we did develop them earlier with the Pythagorean theorem. So, alright, let us discuss some of the ways you can rewrite sine squared plus cosine squared equals 1. So I'm going to go over here and do that. Sine squared plus cosine squared equals 1 can be rewritten, leaving cosine squared on the right and moving sine squared to the left. When you move it to the left, it becomes negative. So all I did was take I left cosine squared there, and I subtracted a sine squared from both sides. Could I not similarly leave sine squared there and move cosine to the other side? If I did that, I would get sine squared x equals 1 minus cosine squared x. So these are all just rearrangements of the basic trig function. And I could continue, I could put the 1 all by its, or the 1 was by itself. I could say, I could go from, how about this one? Cosine squared x minus 1. What would that equal? So that is a rearrangement of this trig ID, and I notice cosine squared is on this side, on the left, and 1 is also, so 1 has been moved over where it became negative. So in order to complete that trig ID, cosine squared minus 1 on this side, cosine squared, move the 1 over, sine squared would have to come over here. In order to do that, it'll become negative. So there are quite a few renditions. So this is a minus when I moved it over. There's quite a few renditions of the basic trig function, and so imagine if we took each of those Pythagorean IDs and rearranged them. Those are the kind of things you're going to need to recognize when you're working these problems we're going to start in a minute. Alright, the next group dealt with sine, cosine, and tangent of a negative angle. And there's a relative of those, it's cosecant, secant, and cotangent, but I'm just going to give you these three, and we'll talk about the others if they come up. So sine of a negative angle equals negative sine of the positive angle. Cosine of a negative angle is the exact same thing as cosine of the positive angle. And tangent of a negative angle is negative the tangent of that positive angle. So we can see that relationship, and I grouped those together because they all deal with the fact there's a negative sign inside the argument. All right. Then the last group that I'm going to bring up today, if I need more, I'll just have to add them to this list. The last group, these and these, come from what I call the other angle. So when we have a trig triangle, a right triangle, and we know one angle, then the other angle is 90 minus theta. Whatever this is going to be 90 minus that. Or we can think of that as pi over 2. And it turns out, and we established all these earlier, this is just like I said, revamping, establishing these. So sine of the other angle, I'll call it, is cosine of the angle. And this could be thought of as 90 degrees as well, either radians or degrees, and the same for all. And the other rendition, cosine of the other angle, is sine of the angle. Tangent and cotangent work that way. That's why we call it tangent and cotangent. Sine and cosine. Secant and cosecant. Secant of the angle is cosecant of the secant of the other angle in the triangle equals cosecant of the first angle. Cosecant of the other angle is secant of the first angle. So these should all be in your book somewhere, and hopefully under the section called Trig IDs. We're going to use those today, and let me shut down and start on part 2. I'll give you 4 examples with all the blab that goes with them. So be right back.